Good evening, YouTube. Good evening, geographers. How are we? Oh, it's getting to that time, isn't it? I love this time of the year when it's becoming really important, really purposeful, and obviously we've got our geography exams just around the corner. 38 hours until we get into that exam hall, getting ready for that paper 1 AQA GCSE Geography. Hit us up in the chat. Let's see who is here, who is in the chat today, who is here. Good to see you guys. This is a very short live stream. It's just a little Q&A, a little question and answer session about the exam and get you feeling ready and prepared, as it were, for that paper 1 physical geography on Wednesday morning, 9 a.m. till 10:30 a.m. Let's see who's here then, who's joined us. I'm conscious to keep it short tonight. I know many of you are revising biology at the moment. Obviously, we've got the biology exam tomorrow. We've got geography on Wednesday morning. I know it's getting busy, so I'm going to keep this to about 20 minutes, okay? 20 minutes max, just to drop in and see how you are and hopefully answer any questions. So it is called the Q&A. We don't normally have a Q&A, but we've got a Q&A. This is your chance to ask any questions about the paper, the structure of the paper, anything on tectonics, anything on living world, anything on coasts, and anything on rivers. Please hit us up in the chat, anything that you're not sure about that you'd want to know. So just a few facts then. Exams are nothing to be feared. Yeah, you shouldn't fear exams, but you should be prepared for those exams. And revision, making revision notes, doing quick quizzes, doing Seneca, doing tutor to you quizzes is really good. But the best thing to be doing now, 38 hours out of the exam, is doing some past paper questions. Have a go at the papers, have a go at the past papers. We've got some shared on our local Showby Drive for those students from our school. But yeah, have a go at the past papers. Have a go at the question. Then have a look at the mark scheme. Anything that you're missing, green pen it, and make sure you revise that green pen stuff, because that's the stuff that you learned. That's the stuff that you didn't know, that you now need to know, and that you've picked up and that you've learned. So don't feel that, oh, I can't have a go at the questions because I don't know the topic. The best way to learn is to make mistakes. Make mistakes, have a go, and then just use the mark scheme to plug those gaps in, to make those improvements, okay? That's what learning is all about. So have a go at that. Okay, something's coming in. So yeah, get your requests in, guys. Couple of questions, first of all. The paper, how long is the paper? How long is the time for the paper? Let's see if we know that. Yeah, hit us up in the chat, guys. How long is the exam paper? Okay. Hey, Rosa, thanks for joining us. Yeah, it's 1 hour, 30 minutes. Yeah, Alexandra, well done. 1 hour, 30 minutes. And how should you spend that time split across the 4 sections? How do you spend that time split across the 4 sections? Now, if you're from other schools watching this, you may complete different sections. But for my school, we complete questions 1, 2, 3, and 4 of paper 1. So question 1 is tectonics and hazards. It also covers weather-related hazards like typhoons, UK extreme weather, which is something that we think we might need to know this year, and climate change. Yeah, climate change. The big one, climate change. The biggest issue currently in geography to be tackled. Question 2 is living world. It covers UK ponds, rainforests, and for our school, hot deserts. Question 3 is coasts, UK coasts, and then question 4 is UK rivers. But how is that split? Yes, perfect. Well done, Bruno. 30 minutes you should be on hazards. So if you get in at 9 o'clock, then all the way till 9:30 on tectonic hazards. And then you've got from 9:30 till 10 a.m. on living world. Remember, our local ecosystem is UK freshwater ponds. So if it says local ecosystem, ours is UK freshwater ponds. Then we've got tropical rainforest, everyone's favorite. We all love a bit of tropical rainforest. And then we specialize in hot desert environments. That's our specialist case study area, is hot desert environments. If you are watching this from other schools, be mindful you might study you might study cold deserts. Then we look at UK coasts, which is right. Question 3, 15 minutes on UK coasts. Make sure you know your Ordnance Survey skills. There's usually a couple of map questions in there. And then question 4 is 15 minutes as well. Okay, 15 minutes. UK rivers is 15 minutes. Make sure you leave enough time for rivers, because a lot of people run out of time on that particular question. So with that in mind, what is the difference between a 4 marker and a 9 marker? What's the difference between a 4 marker and a 9 marker? Yeah, it's 1 mark per minute. Well done, QI. Welcome, QI. Thanks for joining us on our little Q&A. Please ask any questions in the chat tonight. I'll stay as long as you need me, basically. As long as there's questions coming in. Yes, absolutely correct. So your first 9 marker for hazards will include spelling, punctuation, and grammar. So there's only 1 question on this paper that gets required for spelling, punctuation, and grammar, which is the 9 mark hazards essay. Okay, so just keep an eye on that one. Make sure you've got your paragraphs. Try your best to spell things correctly. I know we're not all amazing spellers, and if you know some posh geographical terminology, use that in the 9 mark spag. We'll use it everywhere, but that's in particular where they're looking for your use of geographical language, is in your hazards question. 9 markers, yeah, you must be evaluative. Evaluate the hell out of the answer. What's the most important? What's significant? What's fundamental? What's critical? What's fairly important? Fairly significant? What's less significant? Okay. What's sustainable? What's not sustainable? Those sort of things. So make sure you're evaluating using kind of importance. Yeah, the ladder. We talk about the ladder of importance. What's the most important? And absolutely right, Rosa, you need a conclusion. It is only 2 or 3 lines, but you must use a conclusion, and you must make sure that the words in the question are used in those conclusion sentences. So whatever words you've underlined in the question, put those into your conclusion. Yeah, evaluate, and you must need a conclusion. Good. Okay, so let's think about what's predicted this year then. Who can tell me what is predicted content for paper 1 in 2025? What must you know? What must you know? Just have a cup of tea. It is called cup of tea in case studies, by the way. Hopefully you've got your cup of tea. Yes, absolutely right. Flood hydrographs. It's only been on once in 7 years. Once in 7 years. We think that could come up this year. Flood hydrographs. Yeah, causes of climate change. Absolutely. Causes of climate change is going to potentially be on. The greenhouse effect has never been on. Yeah, how the greenhouse effect works. Management of earthquakes and volcanoes, absolutely. UK extreme weather event. Yeah, on that one, what are you going to use for your UK extreme weather event, guys? What are you going to use for your UK extreme weather event? What case study could you use for UK extreme weather? Let's see what else we've got. Sand dune formation. Yes, that is a predicted content. How sand dunes form over time from your embryo dunes, 4 dunes, yellow dunes, that sort of thing. Succession. Yes, extreme weather events are Somerset floods and Boscastle. Boscastle floods. Again, if you're watching from other schools, you might have slightly different case studies. But whatever you've got for river flooding, whichever case study you have for river flooding, you can use for UK extreme weather. So you can only learn, you only have to learn 1 case study, and you can use it twice if you're smart. Okay. So Somerset levels floods, extreme weather event, or you could use Boscastle floods. That was an extreme UK weather event as well. Other ones you might use, 2018 Beast from the East. March 2018 was the extreme snow and cold event. You may also want to use I think it's summer of 2022, which was the hottest temperatures we ever had on record, which is 40 degrees. Arguably, you could probably get away with the recent weather patterns that we've experienced now. Between March and May, we've had the driest April on record. This is the driest period from March to May we've ever had. There is a lack of water in reservoirs around the UK already. It's not as extreme as the other case studies, but we are in an unusual period of dry weather. Welcome, Somerset weather. Somerset floods. Great case study. Definitely learn that one. Definitely learn your Somerset case study. That would be really good. What else we got? Thanks for helping out, QI. Yeah, these ones are for paper 2. Yeah, paper 2. So don't worry about those for the time being. Just leave those. Just park those up for the moment. They are paper 2. So I think we've got most of the predicted content. Desertification came up as well. Desertification. Okay, it came up as a predicted area of content. Right, let's quickly just do a little screen share. So this has literally been shared with me in the last hour. Okay, and we can have a look around here. So this comes from Internet Geography. Let me just share the screen here, guys. So literally he's just produced this in the last hour. Present. Let's go to screen share. And we want this one here. Okay, hopefully you guys can see this now on screen. So this is everything for paper 1. Hopefully it's coming up. There we go. This is everything for paper 1 that we've got as content. You might need to zoom in, depending on how big your screen is or your TV. So question 1 will be hazards. The movement of plate boundaries, things like convection currents is how plates move. And you've also got slab pull and ridge push as well. Location of earthquakes and volcanoes on plate boundaries, linear formation. They're in certain areas around the Pacific Ring of Fire. That's the kind of distribution stuff. Make sure you know your 3 plate boundaries: constructive, destructive, and conservative. You've got to know your plate boundaries. Really, really important. Sorry, I've just seen a question in the chat there. Plate theory. So plate tectonic theory is what causes plates to move. So we know that tectonic plates move because of convection currents. So these are flows of molten rock in the mantle, which then cause the plate above it to move, in different directions. You've also got ridge push, which is at constructive. Magma rises up and it pushes the plates apart, forcing the plates to move. So plates move because of rising magma at constructive boundaries. And then at destructive, you've got the weight of the tectonic plate pulling down because of gravity, pulling back down into the mantle. So plates move because of gravitational pull of the plates. Convection currents is basically molten rock in the mantle that heats up. As it heats, it rises, and then it cools towards the top of the mantle and then sinks back down, and condenses. So convection currents are flows of molten rock. Imagine a boat on a river. The water moves, and then obviously the boat above it then moves because the water's moving it. Plates move because the mantle is the molten rock in the mantle is moving. As again, any questions that come up, guys, just hit us up in the chat. You're more than welcome. Physical processes leading to hazards. So that's things like volcanic eruptions, leading to things like lava as a hazard, pyroclastic flows as a hazard, ash, volcanic ash is a hazard, gases, volcanic gases are a hazard. So eruptions lead to those sort of hazards. In earthquakes, earth movement can lead to landslides and things like that. That's a hazard. Make sure you know your case studies for hazards, earthquakes and volcanoes. So Haiti and L'Aquila is our earthquakes that we look at as well. And the one that I think most likely this year that you're going to get is these 2 here. These are the ones that you should definitely be revising in the next, 38 hours. Why do people live near hazardous areas? And how do we predict, protect, and plan for volcanic hazards? Okay, hazard management. Make sure you know your hazard management this year. We do feel that's most likely to appear in the tectonics section. Okay, again, if this is kind of new to you or you're not sure of what these things are, we have got 4 videos on this YouTube channel. Watch the hazards 2025 video. It goes through all of that stuff that I've just mentioned there on managing hazards and reasons why people live in hazardous areas. So over at tropical storms, we've got the formation of storms. Make sure you've got a case study for tropical storms. So we looked at Typhoon Haiyan. What is the methods monitoring? Yeah, so well done. Yeah, I'm just looking at the chat here. Sir, how are tropical storms made? Okay, so let's just go to some of the questions here, guys, in the chat. Just come off that for a second. So full screen. A couple of questions coming up in the chat, guys. That's what tonight's all about. So there's no such thing as a silly question. Sadu, thanks for joining us as well. Appreciate you joining us tonight. So how do we monitor tectonic hazards? It depends on which one you are talking about. Let's start with volcanoes. I'll just give you 3 for volcanoes. So for volcanoes, you can monitor gas levels, okay? The amount of volcanic gases being released by the volcano. Sulfur is the most common one. So the amount of sulfur gas released. Also for volcanoes, you can do thermal imaging. So you can actually fly over the volcano and look for heat spots. Yeah. If the volcano is active, you'll get more thermal imagery that's bright white. You've got more magma near the surface. It's more likely to erupt. The third one, perhaps for volcanoes, is finding a water source on the surface of the volcano, a pond, a puddle, a lake that's around the volcano, and measure the temperature of the water. The warmer the water, the more active the volcano is, because that water is being warmed by the magma inside the volcano. So that's for volcanoes. For earthquakes, is much harder to monitor. You can use GPS, so geographical positioning, to see where the plates are moving. You can also use radon gas levels from the plate boundary. They release radon gas from the plate boundary. And what else for earthquakes? Oh, seismographs, measuring the seismic movement of the plate, measuring any vibrations, any movement in the plates can be picked up by a seismometer. So there you go. Hopefully that answers your question, Harry. How do tropical storms form? The convergence of low pressure systems. Yeah. So you've got low pressure, warm rising air. So you've got to have a lot of evaporation. You've got to have this warm rising air, a lot of evaporation, a lot of heat. So you've got heat, you've got moisture, you've got warm rising air, you've got a lot of low pressure. So you've got this rising cell. In fact, let's go to, very quickly, let's go to our camera. Let's go to another screen share here. Stop screen share. Let's go to our camera. This is going to be a very quick sketch here, guys, for tropical storm formation. Okay. So you've got to have 2 major things. So we've got the convergence of air masses. Yeah. So we've got one here and one here. Okay. These air masses are picking up usually moisture from the sea. So here is our sea. And those people in the chat, how warm does the sea need to be to create the storm cell or the ocean? What's the temperature of the sea or ocean need to be to form a storm? Well done, Bruno. You're absolutely smashing those answers, by the way, in the chat. Yeah, GPS, seismometers, tilt meters as well. Yeah, for volcanoes, you are smashing it. Well done. Your revision is really good. And Harry really appreciates that. Okay, Rosa, very good. 26.5 to 27 degrees Celsius. Okay, so ocean temperatures need to be 26.5 to 27 degrees. Okay, you've got moisture rising. So this is moisture. Yeah, being evaporated from the surface of the sea. Yeah, evaporation. So moisture's rising. You've also got, if I got, oh, maybe I can do this here in red. We've got a lot of latent heat. That's heat as well from, oops. We've got latent heat. Yeah, latent heat. So you've got heat, you've got warmth, you've got evaporation, you've got moisture, you've got lots of water being picked up, okay, in here. And that forms huge cumulus, nimbus clouds, or basically storm clouds. You can probably say that, storm clouds, yeah. Remember, this is a low pressure system, low pressure weather system. Yeah, low pressure, because everything's lifting off the earth. It's taking off the earth. It's taking the moisture off. It's taking the heat off. So you get that kind of low pressure system. And then you can form these clouds, and then you can create huge storm cells. Basically, you get storm cell forming. And then the last thing you need is the rotation. Okay, that's not a great diagram now, but you've got the rotation. Hit us up in the chat, guys. What is the rotation of winds called? What do we call the rotation of winds? Rotation of the winds. What do we call the rotation of the winds? I don't know who Bruno's talking to now. Oh, sorry, he's talking to me. You're talking to me. I'll answer that question in a minute. Have we got the answer for this one? What do we call the rotation of winds to create a storm cell? It's based, obviously, on the Earth's rotation. Yeah, the Earth's rotation. So because the Earth rotates, and the most amount of rotation is actually at the equator. If you think about it, the poles only rotate a little bit, but the equator, between the tropics, which is where we find storms, you've got a massive amount of rotation because obviously the Earth spins more on the equator. So this is called, I don't think we've got it, anybody's got it, but it's called the Coriolis effect. It's called the Coriolis effect. Yeah, the Coriolis. Wait a minute, let me just check the spelling of Coriolis. I think it's got double R actually. Coriolis. Oh no, I spelled it right. Yeah, Coriolis. Yeah, Coriolis effect. Just doesn't look right, does it, guys? It doesn't look right, but it is. Coriolis effect. So because the Earth rotates, you get the most rotation on the equator or just north and south of the equator. This is called the Coriolis effect. It causes the winds to spiral. Okay, that's a very quick explanation. Quick recap: convergence of air, warm air rises, picking up moisture from the sea. The sea temperature is about 27 degrees. This moisture rises. It's called low pressure air systems. It forms cumulonimbus or storm cells. The Earth's rotation and the Coriolis effect creates that spiraling winds that you then create a storm cell, such as a hurricane, a typhoon, or a cyclone, depending on which part of the world you live in. Okay, let's go back to full webcam. Let's get rid of that screen share. Okay, what have we got then? So I've got a few questions. How do flowers on a Saragulu cactus attract pollination or reproduction? Help the plant to survive? Well, I think you've answered your own question as far as I can see. So flowers have a single purpose, really, which is to attract insects. They're colourful, they're attractive, they attract the insects. Pollinating insects will then land on the flower. The pollen lands on the animal, on the insect. Then that insect will go between cacti to cacti, cross-pollinating, and then leading to reproduction of the seeds, and then the seeds are dispersed to form the cacti, the new cacti. So I think you kind of answered your own question. Can you do about carbon and temperature levels And tree rings for pollen analysis. Yeah, if you have to prove evidence of climate change, yeah, evidence of climate change, you can. They're fantastic examples. Most people in the country won't be using those as examples, so they're great examples of past climate. So if you're asked a question about past climate change, you can use tree rings, you can use pollen analysis, you can use carbon dating in ice cores, the age of the carbon dioxide that's trapped in ice cores. Paintings, old stories like Christmas Carol, things like that. Right, let's go back to having a look at these this document that was shared with me earlier. Things that could come up this on paper 1. And then, so we've obviously talked about storms there. And then we've got UK weather. Just make sure you know a UK weather event. I say it could be river flooding or the ones we've already mentioned. So for the next section, I'm just going to zoom back in. We've got ecosystems. So this is question 2. Make sure you know your biotic from your abiotic. Biotic means living. So that's any plants or any animals. Abiotic means non-living. So this can include rocks, soil, air, those sort of things. There are others, but that's probably enough. Bit of biology in this one. So make sure you've got your food chains, your food webs. Quite straightforward. And then we've got our tropical rainforest area. So it's things like, why are rainforests important? Plant and animal adaptations is always on, and we think it probably be back on this year for rainforests. Make sure you know your plants and animals of rainforests. Cause of deforestation, impacts of deforestation, and management of rainforests. So that's kind of one big case study, the cause, the impacts, and the management of tropical rainforests. And again, this year we think maybe the value of rainforest could be on. So again, check out our video for question 2 on the YouTube channel. Hot deserts, make sure you know where they are in the world. Animals and plants, again, so cacti and the camel. You might include the fennec fox as well, potentially in that one. And make sure you know your opportunities and challenges of a hot desert. What's our case study? What is our case study desert for opportunities and challenges? Hit us up in the chat if you are from my school. If you're not, still answer. Which desert would you write about if you had to talk about the opportunities, the great things about desert life, and the challenges? Which one would you use? Yes. Well done, guys. So let's have a look what we've got here. I'm just going to minimize this for a second. Let's just get rid of that one. Hello, everybody. Is the sound working? Any sound working? Sir, we can't hear you. Sir, we can't hear you. Is the sound working? That's the question. Oops. Yes. Oh, good stuff, guys. Apologies there. Sorry about that. I don't know what happened. I think it's because I wasn't on the stage. It just cut me off. That's all. This is where we're up to. So Thar Desert, guys, well done. Those people that answered Thar Desert, or the Thar Desert and the Sahara Desert, well done. Just very quickly, give me an opportunity and a challenge of living in a hot desert environment. What would you say in the exam? One opportunity and one challenge of living in the Thar Desert or the Sahara Desert. What would you say? That comes up really often, by the way, probably every 2 years. Opportunities and challenges in hot deserts comes up very often. Excellent. Well, I'm glad the sound is working. Opportunity, mining for gypsum and marble. I like that. That's very specific, Rosa, to the Thar Desert. Superb. Oil and mining, good. Yeah, they're rich in minerals. The Middle Eastern deserts in particular, very rich in oil. Vast amounts of energy supplies. Which energy supplies in particular are you referring to, Bruno? Great access. Oh, I think you've answered it here. Yeah, solar and wind, sustainable renewables. Good. Lots of land for development. Yeah, absolutely. Lots of flat land for development. Good. QI. Mining. Yeah, lots of resources. Farming can be difficult. If you haven't got irrigation, yeah, farming can be very difficult without irrigation. But usually, farming with the right irrigation can be very, very productive. Renewable energies, fantastic stuff. Well done, guys. Yeah, really good. Obviously, we think this year, though, is going to be desertification. So let me just go back to the mind map here. Let's share that back again. Let's just make sure that I'm still on. Here we go. Put me back in the corner. There we go. So we should be on full screen. You can see us now. There you go. So we think causes of desertification. So why deserts are spreading. Climate change, as you can see there. Removal of trees, deforestation, overgrazing, overcultivation are all leading to desertification. And the management of diversification, which is managing the soil, protecting the soil from desertification, tree planting, and stone bunds are appropriate technologies. So, yeah, we really think these bits here are going to come up. Okay, let's drop down into coasts. Let's go on to coasts. So, coastal processes, make sure you are aware of your different types of waves you've got there. Let's just zoom in. So, you've got two types of waves at the coast, destructive and constructive waves. Types of weathering, mechanical, chemical, and biological. That's missing from this one, but yeah, we've got three types of weathering. Mass movement of rocks and your types of erosion, hydraulic action, abrasion, and attrition. If you're ever asked to describe the formation of a waterfall, a V-shaped valley, a gorge, make sure you talk about the types of erosion, hydraulic action, abrasion, and attrition. Explain the processes. Transport of rocks and deposition of rocks. So that's all your processes of coasts. Nice look. It's a little overview, that, isn't it, on the right hand side. Coastal landforms and features. So you've got things like bays and headlands, wave-cut platforms, caves, arches, stacks, and stumps. For depositional landforms, you've got beaches, sand dunes, spits, and bars. And make sure you know a UK coastline with these features on them. So if you're from my school, which case study would you use? Which part of the coast, which UK coastline would you use for landforms? Caves, arches, stacks, and stumps, bays, headlands, sand dunes, spits, and bars. Longshore drift. Yeah, maybe we need to have a little quick look at that. Thanks, QI. Okay, so some things coming up for coast here, which is really good. I'll come to those in a second. Well done, Bruno. The correct answer is the Jurassic Coast. The Jurassic Coast, which is 96 miles long, down in Dorset, south of England, has amazing, amazing coastal landforms. So bays and headlands, you can use Swanage for bays and headlands. For wave-cut platforms, you can use Kimmeridge Bay for wave-cut platforms. Caves, arches, stacks and stumps. It's got to be Studland, which is Old Harry. You'll know Old Harry. Stack. And then for sand dunes and spits and bars, you could use Chesil Beach for spits and bars as well. That area is brilliant, Chesil Beach, for your bars as well. Yeah, Jurassic Coast is the main one. Then we've got also different types of coastal engineering, coastal management, hard engineering, such as seawalls, rock armour, gabions, groins. Soft engineering strategies include beach nourishment, cliff regrading, and dunes, sand dunes. Managed retreat. What is our case study for managed retreat, guys? Can I use water on the naze if I did for paper 3? Yes, you can. Yeah, you can use water on the naze. Yeah, absolutely. That's a good one. Of course you can. Which of our case studies is for managed retreat, where we allow a certain section of the coast to flood with salt water? We've got a 7-kilometre embankment here. It promotes tourism and recreation. It creates a rebalance of the coast. Well done to Bruno, Rosa, Sefinat, Medmary. Well done. QI, yeah, Thames Estuary. The Thames part of the Thames Estuary is managed realignment as well. Well done, you. Yeah, but Medmary in Sussex is Europe's biggest example of managed realignment. For coastal erosion and coastal management, ours is the Holderness. So for coastal management scheme is the Holderness. What is the issue with the Holderness coastal management scheme? What is the issue with the scheme on the Holderness coast? Just a bit of a quick recap there. Overall, it's a relatively successful management scheme, but it has one major problem. What is the major problem with Holderness coastal management scheme? If you want some revision on that as well, check out our YouTube videos on coasts on the channel. And we've got a full section on the Holderness coast, which is very detailed. Terminal groin syndrome. Well done, Rosa. Terminal groin syndrome. First to it. Rock groin cause. Yes. Well done, James. The biggest problem of the Holderness coast management is they've built a rock groin in a village called Mappleton, and it's halting the movement of longshore drift. And ironically, it's increased the rates of erosion further south of that groin. So in places like Cowden, the rates of erosion have increased because of the management in another place. So the bombshell is when you protect one place, you may actually increase erosion elsewhere along the coastline. Okay, let's have a quick look at rivers, and then we'll go to the final questions on the paper. So rivers, I've already got one about hydrographs, so I'll come to that one in a second. So again, you've got to make sure you know your types of erosion. How rivers change in a downstream direction. So from upper course, middle course, and lower course. Things like features in the upper course, middle, and lower. And how the valley changes from V-shape to, to becoming much flatter as it widens out. Going from vertical erosion to lateral erosion as you go further down the river. Fluvial processes there, you've got, it's similar to coasts, hydraulic action, abrasion, attrition, solution. These are all the same as coasts. Transportation. So once you've learned them for coasts, these processes are the same for rivers as they are for coasts. Some people have given me some features: waterfalls, interlocking spurs, upper course. Yeah, well done, QI. Could you explain the difference between concordant? Yeah, I'm going to definitely do that one for you, Bruno. I'll do that in a moment. So river landforms, make sure you know about these ones. Upper catchment features, which QI has mentioned. Interlocking spurs, these interlocking hills, where the river hasn't got enough erosive power, so it goes around the hills. Yeah. Carden Mill Valley has beautiful interlocking spurs. Middle catchment features such as meanders and oxbow lakes. Lower catchment features such as levees, floodplains and estuaries. There is a tip-off that levees could be on your exam. Levees are raised banks of deposition. So when a river floods, it deposits sediment either side on the banks, and then over time this builds up to create these natural banks. They're called levees. Levees and natural banks. Definitely check out levees if you've not revised that. It could be a good tip. Over here we've got river features. So we've got hydrographs. Make sure you know your hydrographs, especially this year. We are going to cover that very briefly. We have covered that in a previous video on the 2025 revision. Hard engineering for rivers includes dams, reservoirs, river straightening or channelization, making the river deeper, making it wider. They did that in Boscastle, by the way. Boscastle, they made the channel, they used diggers to make the channel 3 meters wider and 0.75 meters, just under a meter deeper, to hold more water. Embankments, we've got them in, these are artificial raised banks. We've got those in Branston on the Trent. Branston on the River Trent has embankments, raised artificial banks to stop flooding. Flood relief channels are excess channels that allow water to go into other areas of the drainage basin. So they take water out of the main channel and divert it around settlements or cities or areas of importance. They do this a lot in York, by the way. York has flood relief channels. Soft engineering, natural, sustainable, things like flood warnings, floodplain zoning, not building next to the river, having recreational space and green space next to the river, having infrastructure and residential areas and industry much further away. Burton is a great example of floodplain zoning. Planting trees and restoring the river's natural flow is a really good sustainable strategy. Dredging and planting could come under river restoration. Make sure you know a river flood management scheme. The best ones are Somerset Levels, management of the Somerset Levels, or Boscastle flood management scheme, costing 10 million to protect Boscastle from the 1 in 500 year flood. It's been very effective, actually, Boscastle's flood management scheme. Channelization, flood relief channels, afforestation and tree planting, permeable surfaces for the car park. So the car park now absorbs the excess rainwater. Lots of great things. Oh, and they've even, remember, extended the bridges so there's less obstruction of the channel. The channel is 3 meters wider and 0.75 meters deeper. Great flood management scheme. It hasn't flooded since 2004. Boscastle is a brilliant example of river management, flood management. Okay, so that's all the things there across all of the topics for paper 1. So I'm just going to click stop sharing there. Go back to the stream here. Okay, hydrographs. Some people have been asking about hydrographs. So, yeah, Harry's asked about hydrographs somewhere. I can't find the actual. I think it's a bit early. It must be very early. Flood hydrographs. Here we go. Flood hydrographs. So let me just do a bit of screen sharing again. Go to here. Again, revision doesn't have to be neat. Yeah, it can be just a little sketch, a little bit rough. So with flood hydrographs, I'm going to draw 2 types of hydrographs. They show the amount of rainfall in bars, and they show the discharge of the river as a line. Discharge is the volume of water within the river. This is our peak rainfall. Yeah, remember rainfall's in bars. This is our peak discharge. The time between peak rainfall and peak discharge is called lag time. Yeah, this is discharge. This is rainfall. So this hydrograph here is got a very short lag time. Yeah, it's got a short lag time. So with a short lag time, you've got a few things that are important. You've got water Water reaches the river quickly. And the only way that water reaches river quickly is through surface runoff. Okay, so in the chat, guys, what could cause water to quickly reach the river? What characteristics might there be in that area, either physical or human, that could cause the water to reach the river quickly? What's happening in the local area to the river that means water stays on the surface and gets to the river very quickly? Hit us up in the chat, guys. What causes water to reach the river very quickly? Yeah, so we're getting a few answers here, guys. This is the sort of question that you might be asked. You might be asked, what factors affect the shape of a flood hydrograph? So this hydrograph, this river could be in a V-shaped valley or steep slopes. Yeah, because the water is going to very quickly run down the hill and then straight into the river. What else we got? Deforestation, correct. If you've got less trees, the water is going to very quickly get to the river. Okay, water gets quickly to the river because there's less trees. Yeah, deforestation. What else we got? Geology. Correct. Well done, Harry. Impermeable rocks. Impermeable rocks. Good one would be metamorphic rocks. Metamorphic rocks. Sorry, this is really rough. Metamorphic rocks, such as slate. It's a really good one to remember because slate we use on our roof tiles. And you know that water doesn't go through slate because it's used for roof tiles. Well done, urbanization. This could be an urban area. Tarmac, drainage systems, all lead to this type of hydrograph. This type of hydrograph is called a flashy hydrograph. Remember that. Flashy hydrograph. Because it rises very quickly and it falls very quickly. So a flashy hydrograph is a key term. And this one would lead to flooding. If you see a hydrograph that looks like this, this is classic flooding behavior. Okay. The second hydrographs is basically opposite. So we've got our rainfall here. And our discharge is really low. Okay. Discharge is really low. This hydrograph has a long lag time. So basically the water's taken a while to get to the river. So long lag time. What does this mean? It means that the water is being either intercepted by something, blocked by something, intercepted, or it could be going through the soil as through flow, or it could be going through the rocks as groundwater flow. Okay. It's taken a lot longer to get to the river. So the water's taken a lot longer to get to the river. Either it's been slowed down or it's going through the soil as through flow or it's groundwater flow. Right. So if we think about the opposites of these ones, yeah, so this area could be a flat area. It could be an area with lots of trees. So it could be an area of afforestation. It could be a forest, because this would lead to a lot of interception. Or it could be a rural area, lots of fields, lots of soil, lots of organic things to absorb the rain. So it could be a rural area, okay? Chances are the geology is permeable. So you've got permeable rocks in the area. Permeable rocks absorb and store water. Okay, so basically they absorb and store water. A good example of this is sedimentary rocks. So if the river is near sedimentary rocks, such as, think about it, sandstone. Yeah, you know that sand soaks up water. If you go to the beach, sand soaks up water. So if the whole area where the river is made up of sandstone, then that will absorb water and store it. Okay. So this is a typical type of question that you might get, which is, let me just zoom out. This year we're thinking about hydrographs. So hydrographs, you've got two different types. You've got this one, which is called a flashy hydrograph. This one is a stable hydrograph. Short lag times means surface runoff, flooding. That could be due to these factors. And this one here has got a longer lag time. This one, no flooding, basically. So this river would not flood because the water is being absorbed, intercepted. It's going through the soil or through the rocks. Could be flat areas of countryside, permeable as well. So you've got your two different types there. If this comes up, it'll be 6 marks. It might say, describe the river catchment for a flashy hydrograph. Obviously, describe the river catchment area for one that's not flooding. Okay, so this is how river flooding can cause. This is how factors that affect flood hydrographs. Right, can you hear me now? Are people cutting off the sound? Yeah, it's AQA. It is AQA. Michelle, thank you for joining us. Appreciate you dropping in. Any questions about paper 1? Please, just ask them. Any question. Like, no question is silly. Yeah, ask now. Apparently, the sound's cut off. Give us a thumbs up if you can hear me in the chat still. Okay, there was one other question that we haven't covered, which was concordant and discordant coastlines. Okay, so I'm going to do that one now. Hopefully you can, it's picking me up. So this one is tricky, concordant and discordant coastlines. Let's start with a discordant coastline. Discordant coastline. Okay, good, we can hear us. So discordant coastline is your classic Swanage Bay. This is on the Jurassic coast, basically. The Jurassic coast. So a discordant coastline is when you've got bands of hard rock, soft rock, and hard rock. Okay? So where you've got hard rock, soft rock, and hard rock, these alternating bands, which are at a right angle. This is the sea here. Yeah. So at a right angle to the sea. Okay. So alternating bands of rock at a right angle or perpendicular to the sea. Okay, so here we've got our, you can call it hard rock, soft rock, hard rock, but I like to say resistant rock and less resistant rock. Okay, and then over time, if we fast forward the clock, let's go 50 years in the future or so, or 50 to 100 years in the future, we then, where we've got our resistant rock, we form, yeah, where we've got our resistant rock here, hard rock, we've got our headlands. They are much slower to erode by hydraulic action and abrasion because they're made of resistant rock. Where we've got our softer rock, we've got lots of erosion by hydraulic action and abrasion, and this will form a bay. Yeah. And then on this side, we've then got, again, our harder rock, our resistant rock, and we've got another headland. So if you're asked about discordant coastlines, let me just zoom out a little bit further. If you're asked about discordant coastlines, it's where you've got bands of hard and soft rock at a right angle, 90 degrees, or perpendicular to the coast. Over time, the harder rocks are eroded slower. In fact, that's a key phrase here. Differential rates of erosion, which basically means that the headlands erode slower because they're more resistant rock, and bays erode faster because they're softer, weaker rocks. Yeah, so you've got different rates of erosion, hard and soft rock. I can hear. Yes, Ethan can hear. Yes, nice one, guys. Thanks for confirming. So that's what we mean by discordant coast. Yeah. Now, hopefully that's okay. Let's have a look at a concordant coast. concordant coastline. Our example for a concordant coastline is Lulworth Cove. Again, this is on the Jurassic Coast in Dorset. Jurassic Coast. All right. So what's the difference? Well, the difference is the orientation. The main difference is the orientation of the geology. So this is how they differ between each other. This is the orientation of the geology. So what we've got here, we've got bands of rock of different strengths. Here's the sea. So we've got hard rock, soft rock, and hard rock. Yeah. Or as I know, resistant rock, less resistant rock. Okay. The key thing with a concordant coastline is that we've got alternating bands of rock, horizontal to the coast. Yeah, horizontal is the key thing here. So not at a right angle, not perpendicular, but horizontal. Okay, so that's our key thing. Alternating bands of rock, hard, soft, hard, and they are horizontal to the coast. So the waves are coming in this way. And what happens is over time to form Lulworth Cove. So if we go forward 50 years or 100 years, let's just say 100 years. This takes a long time, this process. Yeah. The hard rock is really difficult to erode. Okay. So that's why it takes ages for the sea to erode through a small gap. So this is called the Portland stone. Portland stone. It's hard, resistant rock. Portland stone. And then we've got our band of softer rocks, which erode much quicker. There we go. We've got our band of softer rocks here. There's our softer rocks. And these are things like clays and shale. Clay and shale rock. Let's just colour the softer band in orange. There we go. So because it's softer, look at how much this area is eroded by hydraulic action and abrasion. Eroded softer rock quicker. And then right at the back, we've got, again, I've got our harder resistant rock. In the case of Lulworth Cove, it's chalk at the back. Yeah. So chalk, which is resistant. Let's just colour our resistant rocks in, what should we do them in purple? So chalk at the back, and it's much slower to erode. So basically the erosion rates are slow at the back. There we go. And basically then you're left with a beautiful circular bay. And a circular bay is called a cove. It's a circular bay. Circular bay. Yeah, it's called a cove. So a concordant coastline, the difference is really the orientation of the rocks between hard, soft, hard. They are horizontal to the coast. And over time, the front rocks are hard and resistant, take a while to erode. Once the waves break through, the softer rocks behind erode much quicker, such as the clays and the shales. And then at the back, you've got the harder rock again, which is the chalk, and that slows down the erosion. We get a perfectly circular erosional feature called a cove, which is basically Lulworth Cove. So that is very quickly the difference between concordant and discordant coastlines. Let me show you the difference in pictures, guys. So let me just quickly get a picture of Swanage Bay in real life. Swanage Bay. We could do with a Swanage Bay aerial picture. I think we need. This was the one that they used in the exams, actually. So let me just get rid of this one. Stop screen share there. Present. Okay. Any questions, guys? We are going to finish up very, very soon. So if you've got any questions about anything we've done are you not sure about, please do ask. So here is Swanage Bay. Hopefully you can see that. Yeah, just zoomed in. So you've got headland, 2 headlands, and then the bay in the middle. That's where the softer geology is in the bay. And then you've got your headlands. Discordant coastline. This is a discordant coastline. They're much more open. The front of the bay is much more open, as you can see. And last but not least, let's have a look at Lulworth Cove, which is discordant coastline. Lulworth Cove, aerial shot. You'll notice it's much more circular. Look at that. Yeah, here's a great, oh, we've got a bigger one. There we go. Great example of Lulworth Cove. You've got your Portland stone right at the front. That's really resistant rock, but the waves have broken through. Look at that. Opened it up behind. Opened it up because of the softer rocks, the clays and the shales, and then the chalk at the back. See how white it is at the back of the picture? That's your chalk. That's your resistant. That's your resistant rock at the back there. Okay, so that's a concordant coastline, much narrower at the front of the bay, much narrower there. So there we go. There you have it. Right. I think we may have, let's just get rid of that. Let's have a look. Thank you, sir. You're more than welcome. Anytime, Bruno. Anytime. Does a bar form from longshore drift like a spit, however, without the change in shape? Yeah, absolutely, Bruno. A bar, in fact, let's quickly go to my scrap of paper. Going through loads of scraps of paper here. Let's quickly go for it. It'll only take literally 2 minutes to talk about bars. So here we go. How do bars form? So we've got our coastline, we've got our headland, we've got our bay, we've got our headland. There we go. So we've got our, here's our bay. Here we go. That's a bay. There's our beach. Here's our headland. Area of land that sticks out into the sea, extends out into the sea. It's resistant. There's our headland again. So longshore drift, swash, backwash, swash, backwash, swash, backwash, swash. The sediment moves along the shoreline. That's why it's called longshore drift. Obviously, the waves hitting the beach at an angle. And basically what happens is longshore drift continues in a straight line across a bay. Yeah. And a bar is formed. A bar is a ridge of sand formed from longshore drift and it connects 2 headlands together. So bars connect headlands together. This is our bar here. I haven't got a yellow at hand. We're just going to do it in orange. That's our sandy bar. A bar is a ridge of sand that connects 2 headlands together. And there we go. And a good example is Chesil Beach. And that is, again, on the Jurassic coast. Chesil Beach, which is a bar. It also traps seawater behind to create a saltwater lagoon, which is basically a saltwater lake. And sometimes we get saltwater plants growing in there as well. So yeah, a bar, a ridge of sand, which joins 2 headlands together, formed by longshore drift. Chesil Beach is your example. We are about to finish this, guys. So any other questions about paper 1? You're going to be absolutely amazing, by the way. I can tell that because the way in which you're asking these questions, the fact that you're asking difficult questions means that you've got a really good knowledge to start with. You're more than welcome. You're more than welcome. Could you explain the 3 types of tectonic movements? Yes, very quickly. Here we go. I've just flipped my camera on. Here we go. So 3 types of tectonic movement. Harry, here we go. So you've got constructive boundaries. Constructive is where 2 plates move in opposite directions. Yeah. Plates move apart. Why do they move apart? Because you've got convection currents. Convection currents, there you go. A good example of this is the Mid-Atlantic Ridge and Iceland. Plates move apart. As plates move apart, magma rises. Also, when the plates move apart, you get earthquake movement. Magma rises and it creates volcanic activity. It creates shield volcanoes. So we get volcanic activity there. We also get weak earthquakes at constructive. So we get weak earthquakes as the plates move apart. And the reason why they're called constructive is it builds new land. It builds new land in places like Iceland. We get this formation. If you want to be really geeky, this is the North American plate. North American plate. And this one here is the Eurasian plate. Eurasian plate. Okay, that's your constructive with examples and explanation. Destructive. Destructive plates collide together. So plates collide. Okay, we get friction and pressure between the plates, which can create earthquakes. We get earthquakes activity here. The heavier plate, which is the oceanic plate, is heavier and denser. So what happens there is we get it subducting. We get subduction of the plate. Sinks, basically. It sinks below. So it sinks below the continental plate. Good example of this is in the Pacific Ring of Fire. Ring of Fire. If you want to be really geeky, it's the Nazca plate in South America and the South American plate. South American plate. Yeah. And this subduction creates plumes of magma that rise up to create volcanic activity as well. Okay. Last but not least, we've got our conservative plate boundary. Conservative plate boundaries tend to move side by side, often in the same direction, sliding past each other. We get friction and pressure where those crosses are, where they meet. Friction and pressure builds up. We get violent earthquakes here. Violent earthquakes form, but no volcanoes. Example is the San Andreas Fault. The San Andreas Fault, and that is the Pacific plate sliding past or alongside the North American plate. Okay, that's a quick explanation of the 3 plate boundary types: constructive, destructive, and conservative. It has been on before. It was a 9 marker, but yeah, it often comes on as even smaller questions as well. Right, you are more than welcome, guys. Thank you. For the 9 marker, I keep getting band 2. How do I go to band 3? Always, for a 9 marker, you need possibly, I would say, let's just get it in here. You're going to need 4 paragraphs. Okay, you're going to need 4 paragraphs, all right? And you need to follow Peel. Make a point at the start of your paragraph. Explain your points. And then how to get the level 3 is to apply these 2 things. A place, for example, in Lulworth Cove in Dorset, and make a judgment or an opinion. I think this is the most important. I think this is the most significant. I think this is fairly important. I think this is not really a factor. So give a judgment, give an opinion. Okay. Think about the ladder. Most/least important. Yeah, you have to have evaluative language to get to level 3. You need to have evaluative language. Okay. Evaluative language. And then L is link, use words underlined in the question. So in your answer, you must be using the underlined words in your answer. Okay. So 3 paragraphs probably of Peel, and then you need a conclusion, which makes up your 4 paragraphs. Okay. In the conclusion, clearly answer the question. It's a question. Okay. So 3 to 4 paragraphs. Yeah. But you must have a conclusion and make sure you apply. This is level 3. This is where, if you're getting level 2s, you're doing a lot of these ones. Yeah. These are level 1 and 2. You're making a point, you're explaining your point, but you're not really evaluating it. You're not giving a judgment. You're not saying if something's sustainable or not. You're not saying if something's important or not. And you're probably not mentioning place. Hopefully that's okay for you. That's how you get level 3s. So do plates move just because of the process going on at each boundary? Yes. Plates move because of convection currents, slab pull, and ridge push. That's what causes the plates to move. You are more than welcome, QI. Remember to peel paragraph, point, explain, apply a place and an opinion, and link using the words in the question. You are welcome. Right, I think we've finished there, guys. Hopefully you feel ready for paper 1. You've got about 38 hours of final prep time and revision and whatever else you need to do. Make sure you rest. Make sure you rest up. Make sure you have a bit of fun as well. It is an exam. You're all taking it really seriously. I can see that with your revision. You're all going to do really well. Don't get stressed. Enjoy it. Show them how good you are at geography. Show off with your words. Show off with your knowledge. You will be fantastic. Go get them grade 7, 8s and 9s. You can do it. I know you can. Right, we're going to end it there, guys. Thank you very much for watching. I'll see you tomorrow for our briefing in the exams. And if I don't see you and you're watching on catch up, or if you're watching from elsewhere around the world, you take care. Best of luck with your paper 1 geography exam, and keep following the channel for paper 2 content. Hit the like, hit the subscribe, and we are out. Take care, guys. Bye-bye. Bye.